we can make a positive edge triggered as well. Very similar concept will be used, and we'll see that in the further clips. So if you have understood that the flip-flop is a combination of latches, and for flip-flop the output is edge triggered and not level triggered, and that's the explanation in front of you. Now we'll go ahead and make an SR flip-flop. So this is nothing but my SR latch, which we have already seen. This is the block diagram of that SR latch. This is my SR latch 1, this is my SR latch 2, where the enabled signal to the first one is clock and the enabled signal to the second one is from an inverter, which we just saw in the basics right now. So this becomes my SR flip-flop now. We have already seen the representation of an SR latch at the static CMOS style in the previous clip. This I have drawn it again just for your understanding, but you can refer to the previous clips to see how this is implemented. And the change here is we'll draw this same circuit twice, 1 and 2 times, and the only change would be the enabled signal to the first one is C and the enabled signal to the next one will be inverted and will be going. And I will call this externally clock, and when it's inverted it's clock bar, and this combination of latch 1 and latch 2 will give me an edge triggered circuit, which is nothing but a flip-flop, and in this case is a negative edge triggered SR flip-flop at the static CMOS style. We have already seen how to implement it in Pseudo NMOS, dynamic and pass transistor, transmission gate and C-square MOS style and SR latch. What we need to change in that circuit is connect a cascade latch where the first latch has enabled signal equal to clock or logic high, and the second latch gets an inverted enabled signal or the clock signal, and it's nothing but a clock bar, and that will be the simple implementation of Pseudo NMOS and different styles of logic for an SR flip-flop. In simple words, in summary, I have also drawn how to implement a D flip-flop and a JK flip-flop at static style and different styles. I have drawn the block diagram of a D latch. I have drawn the symbol. We have already seen the static implementation. So D latch 1, D latch 2, first gets a clock, second gets a clock bar inverted. This static implementation needs to be replicated twice, with first getting a clock to its enable and the second one getting a clock bar at its enable at the transistor level. You can easily do this, thus the inputs needs to change and you need to connect cascaded latches and it becomes a D flip-flop. Similarly, we can do the same for JK latch. This is a block diagram of a JK latch, JK flip-flop, the first one being clock, the other one being an inversion, clock bar, and this is nothing but a JK flip-flop. Similar to static style, we can implement it in all the other styles also, just we need to cascade the latches and ensure that the first one gets a clock and the second one gets an inverted clock. That becomes a negative edge triggered. If you want a positive edge triggered, the first one should operate on clock bar and the second one should operate on clock, and that becomes positive edge triggered flip-flop. So in this slide or in this video, we saw the difference between latch and the flip-flop and how to implement an SR, D and JK flip-flop at static style, and from there on we can implement it in all the different styles. Hope you have followed. Stay tuned and thank you very much.